Paula McNutt. I'm the Academic Vice President and Dean of the College at Carroll. I feel a little schizophrenic sometimes having both of those roles. I'm welcoming you on behalf of Dr. Thomas Trabon, the President of Carroll, who unfortunately couldn't be here today, and sends his welcome to you all. This is the second of these meetings that I've been able to attend, and I think that this initiative is really a very, very important one, and I think it's really wonderful to see how passionate everyone is about the importance of science and math and moving forward on this initiative. I've been in Montana just now I've actually been at Carroll for now just exactly a year officially, and I'm really happy to be back in Montana. I was at the University of Montana for a few years in the 80s, and I really feel like I've come home, so it's really nice to be back in Montana again. I just want to really just quickly, in addition to welcoming you, say thank you to all of you who are here, to all of the presenters who are participating in this program today. But in particular, I want to thank the following for participation in this important venture. Governor Brian Schweitzer is here with us today. President George Dennison from the University of Montana, who I think is responsible for really having organized this whole thing. President Cruzado from Montana State University. I don't think she's here yet.
She'll be here.
Okay. And then State Superintendent Denny, no, I haven't seen Denny either, but and then also our guest speaker, Howard Gobstein from the Association of Public and Land Grant Universities. I think that this is just the presence of all of these folks here today really, I think, speaks very well to the importance of what we're trying to do. So I don't want to take up any more of your time. Welcome to you all. If you need anything during the course of the day, please feel free to come and find me, and I'll see what I can do to help you out. Okay? So I'm going to introduce President George Dennison, who's I think going to introduce the
Thank you.
And I want to add my voice, you've heard it several times, thanking you all for giving up your time and coming to do what is increasingly critical work in the state. The most recent announcement we have of not having made it in race to the top the first time, it seems to me as an indication that this kind of work needs to go forward, and as a result of that, we certainly will reclaim the position that we need to have. About, I guess it's almost 6 years ago now, a man ran for the governorship of the state of Montana and won. And as almost his first act, he announced that we needed to have increasing emphasis on science and technology if we were going to advance the state. That theme has been present, I think, throughout his years in the governorship, and is certainly there present today. The governor and the First Lady have been very influential in raising awareness of the need for more systematic effort in science and technology. About 2 years ago, all of us here, decided that we ought to get on board and play a little larger part in this effort, and have, I think, been fairly successful in bringing people together for a conversation. You who have been involved in it all along know that we had to start someplace, as did most states. Starting someplace was starting at the point of trying to understand exactly what our situation is. So we've been spending some time doing that and getting from that into what the strategies are that can help us go. But I want to say that an emphasis for all of us has come from the Executive Mansion, and it's a very great pleasure to have an opportunity to introduce the governor here this morning for a discussion of his view on science and technology and why this initiative makes a great deal of sense. Brian Schweitzer, as I say, has been governor for 6 years. Fortunately, he'll only have 2 more. He was asking me just a little while ago, how long is it before you start speaking truth? He knows that I'm retiring here relatively soon if they ever find a successor. They can't find a real replacement. They'll find someone who will take over the job. But then nevertheless, I told him that it seemed to me he's been doing that since his first day in office. Please, if you will, welcome the Honorable Brian Schweitzer, Governor.
First question I was asked when I walked in here today, and they didn't look me in the eyes, they looked down and they say, "Where's Jay?" That dang dog, everywhere I go, he gets that kind of treatment. But I was in Anaconda, and we were dedicating a new correction facility to give people a new start. And while I was speaking, he was supposed to be laying beside me, and while I was speaking, he ran out there and he started shaking paws with everybody in the front row. And so I said, "Jake, get back over here and sit down." And then they booed me. You got to have a little discipline with your dog. You can't just let them go out and do that sort of thing. We are interested in science and math. And no better place to talk about science than right here at Carroll College. Now, many of you who are from Helena, you know the story of Carroll College, but for those of you who aren't, you need to hear this story because it's an exciting story. You know that this town is a gold mining town, and there were a lot of fortunes made here. But there was kind of a roustabout fellow by the name of Tom Cruise. Not the Tom Cruise that jumped on the couch with Oprah Winfrey, a different one. This was an Irish immigrant. He was a teamster, and he was delivering goods from the Missouri River. When the steamboats came up, they could only get as far as the Great Falls of the Missouri, and so they carried these things overland. Well, he made his living carrying things overland, and at some point, he just got really lucky, and he filed a patent on a mountain, started mining there, and he hit the richest gold deposit in the history of Montana, called the Drumlumman Mine, Marysville, not far from here. In 1898, he had made enough money and mined enough gold that it was time for him to think about other ventures, and his daughter was just 2 years old. And so he went to the bishop, and he said to him that he would like him to build a cathedral, a grand cathedral, and he gave him the plans. And it was something like 20 times larger than a cathedral that he had thought of in Ireland. And he asked him to make this cathedral a certain size with 4 spires. And the bishop was excited for this donation. It was enough certainly to build this grand cathedral. And he started actually laying the foundation. And he came back to Thomas Cruise and he said, "I have no right to ask you this, Mr. Cruise, but I know that this grand cathedral will be so that your dream comes true and your daughter will be married in this grand cathedral when she does marry. But I've always had a dream." He said, "I came from back east. I was a man of arts and letters. I was an educator, and I don't know why the Holy Father sent me to this mining town, but he did. And so my dream is always to be an educator." And so he asked Tom Cruise on that day, "Would it be okay if we used half of the money to build a college, and we'll build the cathedral with just 2 spires, but we'll build a college?" And they called that college Bishop Carroll College. And so this was built on gold. Now, let's talk about the gold mine for just a little bit. Some Germans bought this thing. Some German engineering company bought it, and they mined it for about 8 or 9 years, and the vein kind of petered out, and there wasn't much gold, and then somebody else bought it, and then there was a big lawsuit. Some out-of-state company owned a portion of the mountain, and another in-state company owned a portion of the mountain, and they went to the judge and had a bunch of lawyers, and they fought this thing out. Of course, the home team won. But in the meantime, the mine was flooded, and there was no mining going on there. So a Canadian company 3 years ago bought the mining patent, and just on a guess that maybe there was a quartz body that would be a little deeper in the mountain, and they poured just 180 feet straight in from where the Germans stopped mining over 100 years ago. And they hit the Charlie vein, which is the richest vein in the history of Montana. I stood inside the mine with engineers from Canada and South Africa, and they all agreed that there is no vein in the world that has 8 ounces of gold and 55 ounces of silver, and that's what they're mining at the Drumlumman mine, and it was sitting there for 100 years, nobody mining it. So there's a success story. You can still make a buck in Montana. Now, how do we create young scientists? When are young scientists formed? And we were just talking a little bit earlier about, is it genetic, or is it their environment? This is an argument that's as old as scientists themselves. And my wife and I have talked about that. Both of us are scientists. And when was it in our life that we decided that this is kind of an area that we like better than other areas? And it was 3rd and 4th grade. And I believe that that's when kids get that spark. And maybe they get the spark from their parents. Maybe they get that spark from a book that they read. But usually, at least in both of our cases, we can trace it to a single teacher. My single teacher was a woman by the name of Mrs. Deegan. She has a first name, but I'll never know what it is, because to me, it was Mrs. Deegan. And it was either the 4th or 5th grade, can't remember exactly, but Mrs. Deegan was like most of the teachers in our community around Geyser. She was married to a farmer, a recent graduate from college, and married this farmer and moved into the community. And she was just a good young teacher, and she only taught for a couple of years, and then she got pregnant, started raising family, and Mrs. Deegan didn't have a lot of generations of kids that she taught, but she taught me, and I still remember the spark. She gave us an opportunity to write a paper, and we were to draw out of a hat, and she put like 200 different topics in a hat, and there were only 9 kids in our class. What are you laughing at? It's a Class C school, which is respectable. And we reached in, and I pulled out the name Argentina. Now, when you're in 4th or 5th grade, it's not a big report that you write, but then I read about this place in Argentina, the Pampas, where the topsoil was black and as much as 10 feet thick, and that the native grass would grow as tall as the saddle horn on a horse, and the number of cattle that you could raise per acre on the Pampas. And the reason that the Pampas was so black, where the soil had come from the Andes, how it had arrived there. And all of this, for this farm kid who thought he lived in the place with the best grass, it sparked my attention to how the land is formed. And so now fast forward, I go to college, I study agronomy at Colorado State, not a bad place to start, right, George? And soil science and graduate at Montana State University, and then went around the world as a soil scientist. But it wasn't until I was 34 years old that I stood in the Pampas and saw the grass that I dreamed about for so many years. And here's what I found. Remember I said that the grass grew as tall as the saddle horn of the horse? They got really short horses. We've been hearing politicians. They're always talking about how they're going to change the world. Sometimes they win elections just by saying there's going to be change. Probably this next election, it'll all be about change. But I've got a little secret for you here. I guess we're on YouTube right now, so maybe I shouldn't say it, but I will. Politicians don't change the world. Engineers change the world. Scientists and ideas and innovation change the world. Now, politicians can talk about change. Business people buy and sell the change. Journalists write the change. Everybody has a place in the change. But the innovation comes from the engineer themselves, the scientists. In Montana's case, we are probably the most important energy state in America, not just because of our coal and our wind and our oil and gas, but also because of where we're situated. We're between Wyoming and Alberta. We're close to the West Coast. We will continue to develop our energy resources in Montana, but we cherish the land and our wildlife and our water so much that we will develop our energy on our own terms. We will not be beholden to the demands of the people who want to consume the energy, because we will continue to protect our water resources and our open space and our wildlife. That's important to us in Montana. In order for us to get it right, in order for us to develop energy, we need engineers. And I know where those engineers are. The ones who will change the world, the ones who will create the wealth in Montana, the ones who will decide the future of energy for the entire world. They're in the 3rd grade, 4th grade, 5th grade, 6th grade, and they're in Montana schools today. What we need is teachers to spark the flame, to create the heat, because it is the teachers who create the engineers who will change the world. And that's what we're here to do today. That's what we're interested in. How do we finance this change that we'll have in Montana? Where do the resources come from? And how many resources do we put with that 3rd grade teacher and that College of Technology engineer creator? How do we find the money and where do we put the money? That's what we're doing here today, deciding how much. I've got some ideas, and I'll be talking about those during the next couple of months. But I'll just give you a spark, and maybe the flame can grow from there. We know that just a few deals that we've made recently in Montana is going to generate $7.5 billion for the state of Montana. $2.5 billion from the Otter Creek tracts are going to go directly to K-12. $2.5 billion over the next 30 years. An additional $5 billion will be raised through the coal severance tax. Just to give you an idea how big that is, in the history of Montana, we haven't mined yet 1.5 billion ton of coal. This one mine will have 1.5 billion ton of coal. In the history of Montana, we still haven't collected $800 million in coal severance tax, and this one mine will collect during the next 30 years $5 billion in coal severance tax. So I think if we're looking for resources to create the change, no better place than to look at old energy to pay for new engineers. And this is something we can create today that will affect the future of Montana for the next 50 years. It starts with money, and it goes to engineers. God bless you. Thank you.
Good morning. My name is Royce Singstrom. I'm the provost at the University of Montana in Missoula. It's a great pleasure to be here today, and it's my distinct pleasure to introduce to you our speaker this morning, Howard Gobstein. Howard is from APLU, that's the Association for Public and Land Grant Universities. It used to have a different funny name that no one could pronounce, but now it's APLU. And Howard is the person who really oversees the science and math teacher imperative that APLU is sponsoring over these last few years. Howard is, in fact, the #2 person at APLU. He is the executive officer and the vice president for research, innovation, and STEM education. He's been at APLU for 5 years. Prior to that, he actually worked 15 years for both UM and MSU. It was the other UM and the other MSU, University of Michigan and Michigan State University, which is why you all gave me a funny look. You don't remember seeing Howard on your campus for 15 years. But he was involved in science policy and federal relations for both UM and MSU, and worked for President Peter McPherson, who is now the president of this APLU organization. So when Peter went to APLU as president, he took Howard along with him to oversee a whole portfolio of programs. So Howard works to oversee not just the science and math teacher imperative that we're talking about here today. He also oversees the Council on Research Policy and Graduate Education for APLU, and he also oversees the Committee on Innovation, Competitiveness, and Economic Prosperity. So he's really very involved in cutting-edge issues that we all face as a nation and here in Montana. Howard's background is in science and science policy. He got an undergraduate degree in engineering from Purdue University, and then he went on to get a graduate degree in science policy from George Washington University in the DC area. Prior to getting involved in higher education, he spent 11 years with the Government Accounting Office in DC, working on the evaluation of science education projects that the federal government sponsored. His wife is also involved in higher education, and in fact works with APLU, not exactly for APLU, on an African initiative. This is another major initiative of APLU, and one that at the University of Montana we've been involved in. So it's a pleasure for me to introduce Howard to you. Tricia, thank you for making the contact with Howard and making the arrangements. Howard and I were just together a week ago in Portland at a meeting of academic officers. Joe Feddock was there as well, and so we had a chance to talk. Howard's going to give us the context of the national scene with respect to STEM education and the science and math teacher imperative. He's going to talk to us about how we react to that national imperative at the state level, give us some examples of what some other states are doing, and present some challenges to us here in Montana as we move forward with our Montana Math and Science Teacher Initiative. Howard, thanks so much for coming, and welcome to Montana.
Thank you all very much for having me here. I think that this is more of a learning opportunity for me than perhaps it is for you, in that we in Washington just get an opportunity to think about things like this. We're sort of at the conceptual level. You're at the level where you're actually getting things done. You're working with schools, you're working with programs, you're working with institutions. So I've come here to learn from you, and I really appreciate this opportunity to do so. Before I get into anything I'm about to say, I have a very, very important question. How do I advance these slides? Trish, do I just do that manually?
Just a click.
Let me do that then. So, looking today at your agenda, it would appear to you, I'm going to move around, is that going to?
That's fine.
Okay. It appears to me that you've got it all together. I mean, you have university roles, obviously, stimulated in part perhaps by the leadership of your universities. You're working on state and local standards. You're working on systematic data collection, teacher evaluation, feedback to institutions on the teacher preparation programs, digital learning, which is certainly going to be key, and then, of course, a communications plan across the state. So, all the more reason for me to learn how you actually get this done at a state level. What I'd like to do is I'd like to give you a little context. What I'd like to do, I think I'm going to have to do 2 computers at once here. I'd like to start by talking about a national context. Again, a reminder as to not only how did we get into this recently, but where are we going with it and what's going on with national scale institutions, organizations, associations, and so on. What's the problem? As we began the Science and Mathematics Teacher Imperative with then Nostalgic, now APLU, so I pronounced that unpronounceable name, we found it very important to try to understand, well, is it just a question of numbers of teachers? Is it a question of quality of teachers, types of teachers, and so on? I'd like to get a little into that. I'd like to get into how our teacher imperative, we call it SMTI, SMTI, the Science and Mathematics Teacher Imperative, what we're trying to do on a national level, across states, to try to address the problem. But then, most importantly, talk about states and regions, as I mentioned, where the action's really occurring. And then end with some key challenges, both for you and for us. So to start, my premise, but I think it's a very easy one here, this is the time for us. It's a time for us, probably the best opportunity in all of our careers to really make a big difference in STEM education. But I also think it's the most critical time. And I think it's the most critical time in that we've got national leaders, both in the Congress and in the administration. That is the president there taking over the shoulder of the head of the National Science Foundation at the time, Arden Brement, talking about both the necessary progress that we need to make in STEM education, also talking about the role, very important role, of teachers, science, and engineering. And obviously here, you are blessed with a governor and a first lady who are both engaged in this and passionate and show it on their own. And with your own initiative here, you're showing why it's important to make it happen. Now, there is a swirl of national activity going on, which is a little daunting. It's also a little confusing. Not to necessarily go through this whole thing, but starting with the National Governors Association, the Chief State School Officers, the Chief, you have the Common Core Standards, as we'll be talking a little about later on this afternoon. You have Data Quality Campaign, which is working across states as to how you knit this together, the metrics, how you find accountability in all of this. Working on down, you have dozens of agendas from industry. There's a new group that we probably all need to watch called Change the Equation. It came out of some opportunities with the Obama administration. And that group is going to form a national coalition of 100 major corporations. It was formed by Xerox, by Kodak, by Intel, by the Gates Foundation, the Carnegie Foundations. They're looking to form a coalition of 100 major corporations all involved in STEM education to see if it is possible to attempt to further align what they're doing. This is all at the CEO level. The announcement's going to come at the White House, I believe it's September 16th. And they just hired a new executive officer, Linda Rosen. Of course, we're all aware of the federal government and how this Department of Education and this president is attempting to leverage huge amounts of money, probably more than any of us have ever seen related to these areas, in its Race to the Top, the Innovation Fund, and so on, to try to promote change in STEM education and how states, school systems, and universities operate. Let me go now a little to the national context. So in a recent book put out by the Urban Institute on education, Alan Blinder, if the name's not familiar, you might remember he was formerly of the Federal Reserve. He was on the Council of Economic Advisors. He's a Princeton economics professor. He poses, in his view, that we've actually gone through 3 industrial revolutions. We're all familiar with the first one, farm to factory. We're all familiar with the second one, which we're in a sense still in the midst of, and that's factory to services. What he also says, however, is that, particularly in the second one, as the portion of the labor force shrinks in manufacturing, and of course we're losing jobs to offshore, there's actually, his premise is there's a third fundamental transformation going on. And that is not only services to IT and automation, but increasingly to a loss of jobs in services to offshore employment. Increasingly at higher level jobs too. We're all familiar with the call centers and so on, which information technology allowed to occur. But now services such as analysis of x-rays going overseas, financial services, now engineering design and software development. And his premise, as I say here in the last bullet, the U.S. cannot outcompete other countries in low wages. There's just no way we can do that. We're all familiar with this challenge. So the only way to compete is based on creativity and talent developed in education here in this nation. Now, what is a little scary to folks, and I'm sure it's not as well understood, is that this is now happening in services, something that we thought that here in the United States would not be going offshore as much as we had expected. So the last point that he makes is all too often our schools, which did a fabulous job in that first transformation from farm to factory, our schools are still many times and all too often still at that first stage, and they haven't gone to the third stage. Even in terms of how we train students, almost essentially getting them ready for a career in a factory, which of course does not happen as often as it used to. So here we have a reminder, if you will, of where probably today's intense interest got started. 2005-2006 report, I think we've all heard of it, Rising Above the Gathering Storm. It was requested by a bipartisan group of leaders from the U.S. Congress, by the National Research Council, and it began with the premise that economic studies conducted before information technology revolution have shown that as much as 85% of measured growth in the U.S. income came from technology sources or somehow related to technological change. From there, they talked about deeply concerned that the science and technological building blocks of the nation are not as well competitive internationally when many other nations are gathering strength. But then finally, where they led to is the most important thing that we as a nation can do would be to improve K-12 science and mathematics education. And you all might remember that the absolute first recommendation that they put in priority order in that report was their recommendation annually recruit 10,000 science and math teachers across the country. So to them, the statement was not enough science and math teachers. Now we know that that is certainly part of the problem. But as we got involved in this at APLU several years ago, before we launched the Science and Mathematics Teacher Imperative, we found that it's not a problem that people aren't paying attention. It might be a problem that it's the way they're paying attention. We found across our campuses there were over 500 discernible math and science teacher preparation programs. So it's not that we weren't doing anything. But the challenge is Nancy Zimford, who was then president of the University of Cincinnati, now she's the chancellor of the State University of New York system. She said, despite all the studies, despite all the initiatives, all the projects over the last several decades, we have hardly moved the dial. So the problem is we're trying to figure out was how do you gain traction? How do you gain some sort of a sustained effort? How do you gain implementation from all those wonderful reports and all those wonderful recommendations? And how do you get something done? Now, in my own view, as we were looking at this, it was because there wasn't implementation built in to all of these wonderful recommendations. And there wasn't a responsibility by institutions or by regions or by states. So in looking at this 500 discernible math and science teacher preparation programs, Tom Luce, who leads now the National Math and Science Initiative, NMSI, says it's akin to hundreds of pilot lights across the country. And I would continue, without sufficient critical mass, so therefore these lights eventually dim and go out. So the problem then, as we would say, is not that there's not a lot of attention, but what kind of attention was being given. So I want to account here. My colleague Charles Coble, who's really the brains of my operation, he's my co-director here, he's the one who's really the education guru. He came after doing his some assessment on this, to the surprising discovery and further confirmation that there is no comprehensive source of information about effective programs, practices to prepare and develop science and mathematics or STEM teachers more broadly. Now this is coming from an education dean of some 14, 15 years who used to write science textbooks, then was a vice president for education partnerships at the University of North Carolina, and after that was vice president of Education Commission in the States. Two little anecdotes here as I was going through my training period, if you will, learning about this. First, in 2006, I became aware of UTeach, University of Texas, Austin, which I think in any way is a gold standard in preparing science and math teachers. And I remember thinking, well, okay, my job at APLU is going to be very easy. All we have to do is go out and promote UTeach, and all the institutions should just adopt UTeach. And I remember speaking to a pretty aggressive education dean at one of our big campuses, big research-intensive university. And I said, we'll just do UTeach. Why don't we do that? And she snarled at me over the phone and said, ours is better than UTeach. They just get more press. And I guess I have the benefit of not really being in this, and I asked, how do you know? And she almost took my head off, but I can guarantee that her response was not very analytical. And a second vignette similar to that. So about a year later, I was at a symposium at the National Academy of Sciences. Another education dean, and I was standing and talking in the hall with him. We were outside of a breakout room where Mary Ann who was the science dean essentially behind UTeach at University of Texas, she was speaking in the room. And I was speaking to this dean, and I said, we ought to go in and listen to what Mary Ann is having to say. And he said, no, I know all about that. And as we're talking, he became more and more distracted and looked over my shoulder into the room until he finally said, I didn't know that. And he brings me back into the room so he can listen to what Mary Ann was saying. And that led me to the recognition that there's a very inefficient flow of information going across our campuses, whether it be across those 500 institutions and their programs, or whether it be however we define what leadership and good programs are. And in fact, that was recently, and this is very recent, this is within the last month or so, really highlighted by a National Research Council report. If you can't read that very well, I very highly recommend this report, Preparing Teachers, Building Evidence for Sound Policy. Now this is for all of teacher preparation, but there is a focus in it on reading, mathematics, and science. This is a report that was very long in coming to show how difficult it was. This is some of the nation's experts in this, and it took them over 5 years to come to some sort of closure on this report. And some of the things that they found, which is interesting, and you're not going to be able to read this because I have far too many words on this screen, is it's exceptionally difficult to assemble a clear picture of teacher preparation. There is no systematic efforts to collect the necessary data. The second is current mechanisms for accountability and quality in teacher education are a patchwork of mandatory and voluntary processes, including state program approval, program accreditation, and teacher licensure and certification, not effectively linked in any coherent way. Although there's an extraordinary amount of work from many fields on questions that influence the effectiveness of teaching, it's only a starting point, and then here, as you might be able to see right over here, there is little firm empirical evidence to support conclusions about the effectiveness of specific approaches in teacher preparation. They end by saying there's no reason, however, to question the recommendations of professional societies, whether they be chemistry or physics and so on. And the research base, though, is strongest for reading and least strong for science. So from that, our conclusion at APLU is this is a different statement of what we think is needed. First, a common definition of quality. Despite some apparently really good university programs, and it's not only you teach, there's certainly others, but what are the common definitions of quality of teacher preparation programs in science and math? There's limited benchmarking or sharing of programs, particularly across various approaches. And there are a good number of approaches now sprouting up, which I think is fabulous, but how are they connecting and how are they communicating? Third, insufficient institutional leadership and commitment to develop and sustain university-wide teacher preparation despite a growth in funding. Now you're showing otherwise, and other states and other institutions are now doing the same thing. And to me, where I sit, it's incredibly exciting to see this really take shape. And then lastly, as you're doing here today, and I applaud you for it, and I do want to learn more from you, link with regional and state efforts. The universities only have a particular niche, maybe a big one, and maybe some leverage, but it's only a particular niche. And unless we connect with cities, with regions, with states, and we learn how to do this together, both in teacher preparation, but all throughout the whole system, in assessment and so on, each part of this is not going to be successful. So, as I look first to start with my university-centric part of the world, universities need to leverage a collective action based on this national consensus. We need the university leadership in concert with key faculty, and particularly in the science and math disciplines. National and state momentum based on common metric and framing of approaches. Extensive cross-pollination across initiatives. And then, as I mentioned, partnerships with other sectors, with education, state government, and business. You wouldn't expect me to come here and not give a pitch for my association, so I had to do that. But just so that you knew, APLU is some 185 institutions. It's large state research universities, including flagships, land grants, and whatever. It's 27 major university systems, and our institutions tend to be large, and they also tend to have large cohorts, undergraduate cohorts of science and math students. So as we started this effort in November 2008, the then head of our effort was Richard Herman. He was a chancellor at University of Illinois, Urbana-Champaign, mathematics background. And he said before his fellow presidents and provosts and chancellors, for too long, institutions like mine have stood aside, and now it's time for us to renew our responsibility. So to have university presidents and chancellors step up and agree to this, to us, was really, really helpful. It was important. It's critical to making this happen. And he was saying that as he was introducing what we now have, and this is just the beginning. Since November 2008, we actually asked presidents of institutions to make a commitment. We need to make it simple. These three elements: increased number, diversity of high-quality mathematics and science teachers, identify the immediate and longer-term needs of science and math teachers in your respective states, and build partnerships, as I said, as critical as they are. Now, a few things with this. Note how it begins by emphasizing quantity, but then embeds that with quality and diversity. But then lastly, it recognizes there isn't a national need. The need is local, the need is statewide. The idea, although it was a rallying point for 10,000 new teachers, to many of us is really meaningless. It's really what you need here in Montana and how you're going to meet the needs here in your state. Although we know increasingly there are some teachers some new teachers that do go from state to state, but still, as a rule, many teachers still stay local. So this gives you a sense. So of those 185 institutions that now make up APLU, I've got 124 of them on board so far across 43 states. And this is, to us, phenomenal. In 14 months after our launch, we were blessed with an opportunity to participate in a White House event. So just in 14 months, we got noticed by the President. And here you have, you can't see this in the light, but here you have President Obama greeting Britt Kerwin, the Chancellor of the University of Maryland System, Bernadette Gray-Lillard from the University of Kansas, and right over Britt Kerwin's shoulder is Phil DeStefano, the Chancellor of the University of Colorado Boulder, and they were, of course, representing our whole group. Very briefly, the strategy that we have for SMITI, as we call it, is university leadership, robust research, innovation, and sharing, determining the state needs, teaming up with select national and regional partners, and facilitate state, federal, fiscal, and policy support. Now, what I'd like to get into here is one of the tools that we are trying to rapidly develop, which is essentially the conceptual backbone of the science and math teacher imperative. As you heard before, my colleague Charles Coble said, there isn't a resource that allows us to compare either entire programs or components of those programs in science and math teacher preparation. So Charles is developing what we're calling it's a taxonomy from his biology background. But this is under intense development. It's based on hundreds of hours of focus groups, site visits, reviews by national experts, and so on. And I have to say that there was actually an early part of this was related to Montana, in that a Montana physicist, Jerry Wheeler, who some of you, particularly probably from Montana State, might remember, he was the head of the National Science Teachers Association. He's back here in the state, but he convened while he was at NSDA an early focus group for us in some national science education experts. This is only here if any of you want to go through this PowerPoint later, but the analytic framework is actually based on a very, very simple and widely used teacher development continuum, from recruitment on the left side all the way through to retention and development on the right side. Okay, so these are early reflections from both my colleague Charles Coble and others working on this. And these are just three models, if you will, or three ideas or examples. The first is a program that you might say is designed or redesigned locally, and that's the University of Colorado Boulder. Now, my colleague Noah Finkelstein, I think, has already told you a lot about what's going on at Boulder when he spoke with you about a year ago or something like that. And he is one of the, in my view, bright young stars across the country helping to develop this. Number two, as I mentioned, University of Texas. Now they're doing something that they're calling a replication of UTeach. I personally I think it should be better adaptation rather than replication, because I think that every circumstance, every institution, every state's a little different. But I think that taking a standard like that and putting it across the country as an opportunity for institutions to adapt to their circumstances is absolutely fabulous, and I applaud both them and also the National Math and Science Initiative that's helping to get this done. But then the third, that some of you probably are familiar with, is Teach for America and some of the things that they do, and certainly the way that they get younger, incredible students involved. I want to pivot a little now and give you an example or two. Again, this is probably more for looking afterwards, but an example or two of two state models that I think are phenomenal. And it might well be that you can gain something from them and perhaps then contribute something further to them as you're moving. This is in Oklahoma. This is the K20 Center, University of Oklahoma, which is a statewide education effort. It's both research and development and demonstration. And it was started and really driven by Mary John O'Hare, who was then a vice provost at the University of Oklahoma. It's based on these 5 phases, as you can see. And phase 1 was something that they built towards after realizing they were heavily involved in teacher development, professional development of teachers in the workforce. But as Mary John told me when I went and visited her a few years ago there, they realized that in order to make this teacher professional development really work, really stick, they had to work with the leaders in the schools and the school systems, the principals and the superintendents. So the University of Oklahoma realized, well, let's start a program for the principals and superintendents, and then let's incorporate that. Let's make sure that that's all integrated into what we're doing with the teachers. Now, as I mentioned, this is a STEM, there's a STEM emphasis, but this is broader than just STEM across the country, across the state. So it's leaders learning, it's whole school learning. As I said here, phase 3, teacher learning, in-depth authentic research and learning experiences for teachers. Then student learning, which includes digital game-based learning, and I know that you're working on some virtual learning as well. And phase 5, connections and collaborations beyond the high school. Now, what's incredible about this is take a look at their partners across the state. They started with a local foundation funding. I believe the Noble Foundation in Oklahoma helped get them started. But take a look at how the incredible breadth of both the funding partners and others. Lower right-hand corner, their partners, they work with more than 500 schools, reaching more than 1,000 leaders, 3,000 teachers, and so on across the state. They have their own building. It's right near the National Weather Center there at the University of Oklahoma. They bring in a lot of National Science Foundation funding right now. It's really an incredible operation. So, K20 Center, you see the website there if you're interested further. Now, Mary John O'Hare was recruited then heavily to do one step better if she could in Kentucky by Lee Todd, University of Kentucky. She's now the education dean at the University of Kentucky. And she has been asked by Lee, tasked by Lee, to do better than Oklahoma. If that's possible, I don't know. So she now has a K20 or a P20 innovation lab in Kentucky, which is just getting off the ground. Again, this is going to be statewide. Again, this is going to be akin to the way the university connects with the entire state and attempting to deal with almost all of the school systems across the state. And again, you can see the breadth of involvement, which is pretty similar to what you have going here. But it gives you an idea of how university-based or university-initiated opportunities across the state can pull others in. I don't yet see as much industry involvement and so on in Kentucky. My next example, my last example at the state level, is a different kind of effort. Now this effort is the Ohio STEM Learning Network. This blew me away. Now I was raised in Ohio, but I'm showing no ownership of this whatsoever. It began with an effort by Ohio State University and Battelle, and some of you might be familiar with the Metro High School in Columbus, Ohio. Metro High School started sort of like a lab school. So it was an opportunity for both research and demonstration in the high school. Again, it's not just a STEM school, but it's heavily STEM focused. They drew on Columbus kids from throughout the Columbus area by lottery. So they got maybe 50% inner city kids. And they realized that this was an opportunity to also cycle teachers through there to learn about transdisciplinary education, heavily information technology based, heavy technology based, and a very, very different feel to the school, to the classrooms. And I believe they just graduated their first graduating class. I think they started at 7th or 8th grade and they worked their way through. So they're 5 or 6 years old. So what did Battelle then do? Battelle then decided, well, let's see if we could use the Metro High School and similar things like that, similar schools like that around the state as hubs, and let's put this on a state level. And that's the Ohio STEM Learning Network. As you can see, enhancing STEM teaching and learning, accelerating existing and emerging STEM initiatives, both in STEM startup schools and related K-8 STEM programs of excellence. And then creating, this is really important, the network of some sort of infrastructure that connects them across the state. And this is you can see their effort around the state. They have major hubs there. And what's really interesting here too is that each of the hubs around the state already had a starting point. I mean, they didn't start from scratch. So in Cincinnati, for instance, in the southwest corner of the state, they already had a cradle-to-career effort called Strive, which, as it turns out, Nancy Zimfer had been involved with. And that is working with industry, with education leaders, with local city leaders to create a set of both indicators and quality and assessment of the entire school system and how they're moving forward. And Strive essentially became the operating group for southwestern Ohio in the Ohio STEM Learning Network. So they managed to connect with ongoing efforts already going on in the state, but each based in both high schools and K-8, as you can see. It's a phenomenal network. What to me is very exciting is now Battelle has connected with Gates. They're taking this into 5 other states. They're just starting this. I don't know where it's going to go, but to me this is a fabulous model. Now, as we turn from this into something that you are all wrestling with, another report just came out. See, in Washington, that's what we do. We just play with words and reports. But another report came out that might be very helpful to you. This one is called Measuring What Matters, a Stronger Accountability Model for Teacher Education. And when I say it just came out, it was last Thursday. I went to this briefing. And Ed Crow, who's been involved with this from the Carnegie Foundation, from Department of Education in the past and whatever, he really challenges us in education without mincing words. The current system doesn't guarantee teacher education program quality. Each state does its own thing in oversight, in tests, and data. Probably sounds pretty familiar. All states should adopt a new system guided by the following principles: program accountability, state accountability, measurable indicators from just a small number of key outcomes that you have a consensus on, accountability and consequences applied to every teacher preparation program across the whole state, and then, of course, full and transparent public disclosure. He's probably not saying anything terribly different from the data quality campaign and others. I've got 1, maybe 2 copies of hardcover, but again, as you saw, there is a website there, American Progress, and you can certainly take a look at it from there. Now, another challenge that I know you've wrestled with on the state level is, how do we know there's a problem? How many science and math teachers do we need? So we at SMITty in APLU had an NSF-funded project in which we have developed a guide, which from my mind, would be very interesting for me to hear from some of you later on, maybe if you've had a chance to look at this, of how this compares to the approach that you took, and whether we got it right based on you actually doing this. 4 principal objectives to help states assess the adequacy of their current science and mathematics teacher workforce, a practical guide, examples and resources, but then also practical and theoretical challenges. And again, you'll see these are the main sections of what it is. It is a website. All the resources are loaded there. And at the bottom of the page here, it's state needs teacherimperative.com is where you can find it. And I'm sure you'll all have access to a copy of this presentation so you can get all the URLs. Some of the key findings and recommendations that we have here. Assessment of the need for teachers inherently involves a decision about not only quantity, but qualifications, as I'm sure you've already gone through. Effective teacher state licensure standards certainly relate to this. And because you're not wanting to leave classrooms empty, sometimes it's not only a matter of vacancies, as I think you all know. teacher supply and demand forecasts should go a little further than just taking a look at the numbers of teachers. Let me suggest a recap of what I've gone through so far before I close with some questions and challenges for you. So we've talked about how we know this is an intense national need, and there's a lot of attention going to all this right now. But we know it's not a question of just how many. We know it's more of a question of how do we know that we're doing the right thing? How do we know that the programs that we have are addressing the problems that we have? Now, in my Smitty university-centric approach, we're working out partnerships. Thank you. And hello, greetings, I'm Howard Gobstein. We're working out partnerships with universities, working out to local cities, states, and we're trying to learn how that's done. We're trying to learn from you how that's done, realizing that this is not easy. I've been talking a lot, for instance, to the president of Florida International University, who's on my new executive committee, and he's working out with Miami-Dade County how they work, because they are providing some 60, 70+% of the teachers from Miami-Dade County, and they're trying to work out a better partnership with the institution. Statewide efforts are critical across institutions, across sectors. I've given you some examples of things that, just in my small view, seem to be really creating some movement here. Remains to be seen how successful they're going to be. What I'd like to do is I'd like to list, at least from my perspective, from the beginning of the day, this list will probably be different at the end of the day after I hear all of you speak, some challenges. So as we define effective teachers and their preparation in science and math, how do we also define effective teachers in broader fields? More than just a chemistry teacher or a physics teacher or a biology teacher and so on. And what does that mean? And how are you going to help, by your definition, help other states to also address the same kind of issues? Because obviously you're not in this alone. How do we develop the potential for sharing of teacher expertise across schools, particularly smaller schools? I mean, we at APLU are wrestling with this on the urban level, because disadvantaged schools in urban communities often don't get the expertise of the teachers that they need as well. But I'm really impressed, and that's why one of the reasons I was really excited about coming out here. How do you address it in a vast state with a lot of smaller schools? How do you incorporate what we're talking about here, the STEM-specific nature of science and math teachers, into the broader educational reform going on both across the state and across the country? Race to the Top, you'll remember, had a STEM focus. Now, of the hundreds of points, 15 points are related to STEM. I got a little bit of it was interesting to watch the crosstalk going on in Washington. Was that too much? Was that a little? Was that a lot? Or whatever? So how do you integrate STEM into broader educational transformation? How do we create an environment and a set of learning communities, if you will, if you allow me the use of that somewhat faddish word, so that you learn from other states, because you're not in this alone. How do you learn from other states and take and glean from what they're doing to best use here in Montana? Now, as we get into state standards, Common Core standards, and so on, how do we align the state standards and the data that you're coming up with those that other states are doing? How do we know that when you're implementing these Common Core standards, however that works for you, how does that relate to what your neighbor states, but also other states across the country are doing? I'm not sure to what extent you've yet had an opportunity to draw in the private sector in this state. In some states, the Ohio STEM Learning Network is a good example. The private sector helped to drive that and create an environment by really stressing the critical need and importance for the state. And they helped to get the education leaders, the university leaders, and particularly the political leaders, and get the political will. Now, you already have a lot of that leadership in place, and certainly impassioned and engaged, but I do wonder if there is a role for the private sector further here. Now, the last point that I have here is to me pretty exciting too. Having been to Metro High and having visited a new tech high in Manor, Texas, outside of Austin, if you haven't been to these schools, or if you're not involved in this kind of a learning environment yourself, it is phenomenal. When I went to New Tech High, I was really impressed by the kinds of problems that they give to middle school students. And I figured, okay, so I'm going to go to a technology-enriched high school. So this is for rich kids. So it was 50% school lunch eligible kids. So that was dispelled. I was certainly wrong on that. And the degree of student interest, excitement in the types of issues that they were wrestling with and how their teachers presented them. They're working in clusters all around computers themselves. They were given problems and they weren't defined as a science problem or whatever. One was, how do you design ships to maximize the amount of oil that they can take and minimize their energy consumption? And these kids were learning about buoyancy, they were learning about all sorts of physics, they were learning all about energy, and they didn't even realize it. And of course, the teacher was more of a guide and a stimulant. It was absolutely phenomenal. So I close with this list of challenges, and maybe my last one to you. So what am I going to tell others about what you're doing? How am I going to add Montana to my list of examples? And what would you have me tell others about what you're doing? And I look forward to learning about that this afternoon, and I look forward to hearing more from you. I thank you.